Imagine a customer comes to you, a software developer, and says, "I need a mobile app." You ask what exact features they need, and they reply, "I don't know. I'll know it when I see it." It sounds strange, but in the software industry, this happens all the time. If you try to use the traditional waterfall model here, development will stall immediately. Waterfall demands completely clear, fixed requirements before a single line of code is written. You cannot build a final product based on guesses. Think about how an architect works. Before pouring the concrete foundation for a new house, they show you a 3D model. You check the model, suggest changes, and only then does the real construction begin. Software engineers use this exact same logic. Before building the complete system, developers create a small working sample called a prototype. It's an early version of the software built specifically to validate what the customer actually wants. By prioritizing a tangible, interactive trial over immediate final coding, the prototype model translates abstract customer ideas into concrete technical requirements before full-scale development begins. Let's map out how this works in practice. Developers gather basic ideas and prepare a simple, quick design. Then they build the prototype itself, focusing entirely on essential user-facing features. You might have a working login screen, but back-end processes are left out. Now the customer tests this early build, providing concrete feedback on the interface. This kicks off the core iteration loop. Developers take that feedback, refine the prototype, and hand it back. This cycle repeats continuously until the customer is satisfied. Because you are iterating on a simple sample rather than fully polished code, discovering misunderstandings and changing requirements early in the cycle becomes significantly cheaper and less risky. Building these extra samples does come with trade-offs. The most obvious friction point is that developing a prototype requires additional time and upfront cost. There is also a psychological risk. When a customer clicks through a working user interface, they often assume the software is finished and ready to ship, not realizing it's only an empty shell. And if developers get lazy, they might try to turn that fragile shell into the final product. Constantly patching and modifying sample code instead of designing a proper architecture leads to a tangled mess of poor quality software. Because of these inherent risks, prototypes are terrible for projects that have strict regulations or highly fixed specifications from day one. Test your understanding. How does the prototype model compare to the waterfall approach when handling requirement changes and customer feedback? The prototype model is built for continuous feedback and easy adaptability. Waterfall, conversely, limits feedback and makes changes incredibly difficult once development begins. Mastering this concept for an exam or interview means connecting 3 specific points: defining the prototype as a trial version used to clarify requirements, mapping the iterative flow, and identifying UI-heavy projects like mobile apps as the ideal use cases. Effectively, developers trade short-term development speed to minimize the risk of building the wrong solution, ensuring the final system aligns with the user's actual needs. But remember, the prototype is still just a throwaway sample. Once requirements are clear, that code is usually discarded so the real, scalable software can be developed from scratch. Which raises a new problem. What if the customer doesn't want a throwaway sample? What if they want a working, usable version delivered immediately, which they can keep and improve over time? Building software that compounds and grows step by step requires a different framework. That approach is called the evolutionary model, and we'll break down exactly how it works in the next lesson.